Okay, so hi everyone. My name is Sotiris Kakavoulis. I'm an engineer in Signal Ocean. Signal Ocean is a company that makes shipping software. So basically, we have some analytics that show the global state of the tanker or dry fleet in the world. And then we use this to make our customers take good decisions faster. So, first of all, Signal is a shipping company that has the software and also uses it. So there are two companies, right? The maritime company is using the software we make. So I have, let me see, sorry. Yeah, okay, I have less than 10 minutes to persuade you to not do this again. Just run away. This is the worst idea ever, but we did it. So I'll tell you how we did it, and then you can decide on your own. Okay, so how we work, basically. So Signal is a company that works with multiple teams, right? We have multiple software teams. We work on the same repository, 3 of us, and we have also some other teams that work on the back end with microservices that we don't really touch that much, so we don't really care about them. Now, on the front end, let's say, on the platform teams, we are 3 multi-location teams. So we work from Athens, London, and from Poland. And we have to kind of make it work, right? From different people on the same code base. This is always a recipe for disaster. So we implement the GitHub flow. You may are familiar with GitHub flow or Git flow. It's a very, very simple Git technique that we make branches from the main branch. Yes, exactly. And then we create the features, we push them back to main, and whatever is in main is our product. That's it. No more, no develops, no releases, nothing. Whatever is in main is our product in production. So what happens is that we create the PRs, we create the branches, we create PRs, dev people and business people go and check what we have created. And if it's all good, then we complete the PR. PR for non-technical people is a pull request. So we request to add some new code to the main branch. So we push the code if everything is okay, and then the automatic trip starts. What happens is that there are automated tests that run, check that the code is okay. If it's okay, then it pushes to a temporary environment. And after that environment, it goes to production and it's available to our customers. So basically, after the PR is completed, normally, there's no human involved. Everything goes to production directly. Usually it's more than 20 minutes. But 20 minutes sounds good, so we add it to the title. But it actually works. We have done this for a few years now. It's been happening since before I joined the company, so it has been refined and fine-tuned, and there was a lot of work there. And let's go to see why we prefer to do it like that. So, how? Yes. So what do you need to do that? Let's say you want also to create a PR, push it to production, push it to your code, and then directly to production. No hustle, no staging or test environment, nothing like that. So what you need is a few things. First of all, you need a very, very well-working development team, or more than one. The problem with that is that, as you understand, whatever goes to the main branch goes to production. So whatever happens there, it's very close to the customer. So you have to trust your development team. You have to know the people that work there and know that whatever they approve is ready to go to production. After that, you need all the technical infrastructure. So you need the pipelines that will take your code and move it to production, the code that will create the pull request, because when the pull request is there, in order for you to, or for the business people to check, you need to have some kind of test environment, right? So this is automatically generated, and you have a little copy of your main application in a separate environment that is with its own data, with its own database, own platform, everything isolated. So then you need a dedicated DevOps team or someone that can do that. After that, you need tests. You need automated tests. I mean, there are a few things that you can check in this temporary environment, right? You can go there, see, okay, the button was changed from blue to green. That's fine, that works. But unintentionally, you went and changed all the buttons to green, so now your whole application, is an array of green buttons, but you didn't really want that. So you have to make sure that this doesn't happen. And the way to do that is either you have, 10 people in a corner that they go every time someone creates a PR and check that all the buttons are blue still, except this one that you really wanted to change. Or you can have robots do this. And I think having the system do that, it's much more realistic. So you need an array of regression tests or an array of different types of tests that will make sure that whatever you have created doesn't break everything that has come before. Of course, this is a lot of work, you understand that, and you probably need a specific and specialized team to make sure that this is there. And after that, so everything is okay, your tests are all green, you are ready to go to production, you press the button, and then the whole trip starts again, and you have to create this, let's say, temporary test environment that you always want to have there because you want to check something and you don't really want to go to your production and change your data. And after this is created, then run tests again one more time, just to be safe with production data, and move to production. So for all this to happen, you need at least 3 teams, right? This is one of the biggest things that this is like a very hard thing to achieve. Okay. Sorry about that. Let's go again. Okay. So, why? Why do that? Why would you like to have this kind of procedure? I mean, it's expensive. You have to hire a QA manager. You have to hire a DevOps guy. These are expensive, hard to find. So, what we have, what are our own observations about this? The first thing and the most important thing is that it's very fast. You have something that you want to push to production. When it's ready and approved and everything has checked it, you click the button, like a few minutes later, it's in production. And actually this works. It's been very, very rare that we had problems with pushing things into production. You have an isolated testing environment. So you want to check it. You don't have to deploy in the same dev environment like 5 people trying to merge all handle the conflicts and all that. Developers will understand that if there's 1 or 2 test environments, then it's a hassle to try to merge all the things and try to have a consistent environment that actually can be checked. There's the same thing again. You don't really need the test environment, so there's no environment that you need to kind of maintain. No need to have the database come like copy from the production and other things that are kind of complex with these environments. You have tests. This is kind of a double-edged sword because many people say, okay, I can have the whole thing, but okay, I will put tests whenever this is feasible, when I have the time or when I have the people. And this is very dangerous because pushing to production so fast, it's desirable, but it can really, really backfire without proper regression testing and proper handling of if something goes wrong. So for us, having regression tests was a big plus for the whole process. And there's a byproduct from these tests that you actually can check that your system, the production system or your test system or wherever you're running the tests is actually functional. So you actually have all the APIs running, all the code is correct, the database is functional, etc. Now, why you wouldn't want to do that? Is there any reason to not do it? I mean, sounds okay, sounds very good. You know, go to production so fast, the system has these monitors. So the reason to not do that is that it's hard, actually. Actually, it's very hard, and it's very costly. So you can start doing it, and having a misbehaving system actually block your deployment, because the tests never pass, because something is always wrong, or the system is never in a good enough state to pass the tests. And there are different parts that you have to make work together. So it's actually hard. It's expensive to do that. If you start doing it, you have to make sure that you'll go all the way. Because if you stop at some point and say, okay, I will do this part and I will leave the tests out, or I will have a kind of automatic deployment, then you have the serious risk of false safety. So you start saying, okay, we have CI/CD, continuous delivery. We push, go directly to production. Yeah, we have some tests. They kind of work. And we bypass them sometimes, but it's fine. We have CI/CD. And then at some point, you may have a very, very bad case of having to roll back. So in conclusion, this is a very good, very nice strategy. But in order to start this, you need at least 3 teams, let's say. And this is expensive, right? And it's hard to find. But if you can do it, then go for it. It's a very good procedure. It's very easy for us developers to work with this kind of systems, and it's faster to deploy to production. But if you think you will not make it, better wait and do it the old-fashioned way. Thank you.